Welcome to student. Now today's lectures we have discussed the topic carbonyl compounds. In these topics we are going to discuss the next mechanism, Claisen-Schmidt reaction. The previous lectures we are going to learn the various types of mechanism as like benzyl condensation or Winchell condensation and their applications. Now we have see Claisen-Schmidt condensation reaction. This type of condensation, it is an aromatic aldehyde without alpha hydrogen atoms and aliphatic aldehyde or ketone having the two alpha hydrogen atom in presence of the strong base like a NaOH or alkoxide to produce unsaturated carbonyl compounds are called as Claisen-Schmidt reaction. The previous lectures we have seen this condensation, which is condensation can be carried out without alpha hydrogen atom, but in Claisen-Schmidt reaction carry out the one of the molecules which contains without alpha hydrogen atoms and other molecules they will have the two alpha hydrogen atom in presence of strong base like NaOH alkoxide to produce the unsaturated carbonyl compound is called as a Claisen-Schmidt reaction. So is Claisen-Schmidt reaction, one molecule is having no alpha hydrogens and one molecule is having two hydrogens. So one molecule of this, it is not containing alpha hydrogen atoms. It is a 3 alpha hydrogen atoms are there, but we are required only 2 forming the unsaturated carbonyl compound. Now we have seen some examples for those Claisen condensation reactions, like this is one of this aldehyde having no alpha hydrogen atoms, it is 2 alpha hydrogen atoms. So OH minus can take the proton from carbanion is here, and those carbanion can attack on this carbonyl carbon form negative charge. So oxygen, which is stabilized by pick up the protons from the water molecules, convert to OH, and after replace the OH to get the product as a unsaturated aldehyde, right? Similarly, this one of these molecules benzaldehyde having no alpha hydrogen atoms, and this acetone or dimethyl ketones will have the total 6 alpha hydrogen. This is a 3 alpha hydrogens, this is other 3 alpha hydrogens. So to formation of any one carbon having carbanion attack on this carbonyl carbon and to form this carbon-carbon double bond is given, right? So this is the 2 examples for Claisen-Schmidt reaction. Now we are going to discuss in detail how the mechanism will carry out by Claisen-Schmidt reaction. In the first step, what happens, formation of carbanion can take place by abstracting the protons. A strong base like OH minus pick up the protons from these carbons. These carbons are alpha hydrogens, 3 alpha hydrogens are there or alpha carbons. So pick up the protons and to form carbanion is here, right? So those carbanion, that is negative charge on this carbon negative charge which is stabilized by this carbonyl carbon to form enolate, right? This is a enol, right? Enol. Okay, this is enol. These enols are stabilized along this carbonyl carbon. Then after formation of this carbanion like this, the second step, nucleophilic addition by carbanion to the carbonyl carbons of aldehyde. So those CH2 minus attack on this carbonyl carbon and to form negative charge on oxygens are here, right? So this is a negative charge on oxygens. And then after formation or nucleophilic addition, then what happens? Third step, proton abstraction can take place. So which protons can abstraction? From the water molecules, right? OH minus pick up the proton from this, so OH minus convert to water, so this H2O, right? So this O minus pick up the proton, right? This pick up the proton from this and to convert OH are here. And then after heating, the loss of water molecules, right? This H and this OH, this H, this OH, so loss of water molecules and to form carbon-carbon double bonds to get unsaturated compounds. The next points we have see Claisen Schmidt reaction of their applications. The first application which are detect the presence of relative methylene compounds, right? Relative methylene compounds. For example, those molecules are named as a camphor, which are naturally occurring perfumery compounds or the chemicals. They can be detected which is present, the such a group which is present, yes or not. So by Claisen Schmidt reaction. So those camphor can treat with this benzaldehyde in presence of NaOH to get unsaturated molecules, and therefore those molecules can show this type of group present, which is this group like this. So this group is present shown by Claisen Schmidt reaction. If it is a present, therefore they form this carbon-carbon double bond is here and to get alpha beta unsaturated ketone. Second applications are there to form unsaturated ketone which is present number of perfumery chemicals, right? Unsaturated ketones, they are perfumery chemicals. Perfumery chemical. Here, this is one of these benzaldehyde. They will containing no alpha hydrogen is there. This is a alpha carbons, right? So 3 alpha hydrogens are there. So strong base abstract the protons to form carbanion, and this carbanion is attack on this carbonyl carbon to form negative charge on oxygens after hydrolysis OH and after removal of water molecules to get these unsaturated compounds which are perfumery chemicals mostly used in the natural products. Similar other carbonyl compounds like acetone or dimethyl ketone can treat with benzaldehyde. It is also 2 carbons, that is alpha carbons, but one of these alpha carbons to form carbanion, this carbon attack on this carbon form negative charge which is by protonation and removal of water molecules to get benzylidene acetone. Similarly, other examples, this benzylidene acetone can treat with another molecules of the benzaldehyde to form these similar products having a dibenzylidene acetone, right? Next type of reactions. Now we are going to learn the Cannizzaro reaction. Cannizzaro reaction, it means the aldehyde without alpha hydrogen atom. The aldehyde containing without alpha hydrogen atom heated with strong alkali like NaOH or other strong base, they undergo self-oxidation reduction reaction and to form alcohol as the one product and other is a salt of carboxylic acid. This is called as a Cannizzaro reaction, right? Cannizzaro reaction, it means the aldehyde containing no hydrogen or without alpha hydrogen atom with strong alkali like NaOH or strong base like other, they can undergo self-oxidation reduction reaction to form alcohol as a one product, other is a salt of carboxylic acid. This is called as a Cannizzaro reaction. Here, this is a formaldehyde. They will not have any alpha hydrogen atom is there. Alpha hydrogen, we know that alpha hydrogen. Alpha hydrogen, it means the hydrogen or the carbon is attached to the functional group, right? The carbon attached to the functional group. It is not there any one carbons, so it is not present alpha carbons are there. So this aldehyde can treat with sodium hydroxide strong base to get one of the product is alcohol like a methyl alcohol and second product is salt like a sodium acetate. Similarly, other examples, that is the benzaldehyde, it is also having no alpha hydrogens are there, are treated with the NaOH to get the product is one alcohol, that is a benzyl alcohol, and second product is sodium benzoate is the salt. Now we have discussed the actual mechanism for those Cannizzaro reaction. Firstly, first step is the formation of oxyanion. So how will you form this oxyanion? For example, those benzaldehyde and the strong base like a OH minus is attack on this carbonyl carbon and to form negative charge on oxygens are gas like this. So it is oxyanion. This is a product is oxyanion, right? One of the mistakes is not good writing, but these products are called as the oxyanion, right? In second step, what happens? Hydride ion shift. Hydride ion shift. The hydride ions from oxyanions can transfer by intermolecularly to carbonyl carbon of the second molecules of aromatic aldehyde having no alpha hydrogen atom, right? So those oxyanion can transfer hydrogens, right? So this O minus can reverse to form carbon oxygen double bond is here, and these hydrogens will transfer to these carbons and to form negative charge on oxygens are here. So one is a acid and one is a sodium salt of the alcohol, that is a CH2O minus. And last step, that is a third step, proton exchange can take place in between two molecules like this acid and this is a anion. So this O minus pick up the protons from this acid and to get carboxylate. It is a sodium carboxylate and one of these product by pick up the protons to convert the alcohol. This is the benzyl alcohol and it is a sodium benzoate, right? Sodium benzoate. It is the product. So this type of mechanism will be theirs in this reaction. Secondly, now we have see applications of Cannizzaro reaction. First applications are to prepare substituted benzoic acid and benzyl alcohols. Substituted benzoic acid and benzyl alcohol. Here, this orthomethoxybenzaldehyde can treat with NaOH to get this benzaldehyde to benzyl alcohol is one product. A second product is a sodium benzoate, like this, one of this benzyl alcohol. This group of the benzaldehyde, they will convert CH2OH is one product, other product is CONA, that is ONA, salt. One is alcohol, one is salt. Similarly, this para-nitrobenzaldehyde can treat to get one product is CH2OH and other product is COONA, right? COONA. So this benzaldehyde, its aldehyde group is converted to one is COONA and other is CH2OH. Similarly, two groups are there, so only one molecules can be taken. It is one of the aldehydes, so two molecules of aldehyde can be taken. It is two aldehyde group. This is a one and this is a second aldehyde group. Therefore, only one molecule can be taken. So one of this aldehyde group convert to acid, that is the sodium salt of the acids, and one of these aldehyde is converted to alcohol, right? So CH2OH and one is sodium salt of the acids and one is CH2OH, that is the alcohols. So this is the applications of Cannizzaro reaction. The next parts we have see the cross Cannizzaro reaction. Cross Cannizzaro reaction, it means when a mixture of the two different aromatic aldehyde, this is a one and this is a other, two different aromatic aldehyde having a no alpha hydrogen atoms are treated with strong alkali, a mixture of the acids and alcohols are obtained, and this is called as a cross Cannizzaro reaction. So how many products are possible? Four products. Which four? This is cell 2, it is a cell 2. Total 4 products are possible. So this is CH2. For example, this is one of the benzaldehyde is converted to the right sodium salt of acid, and one of the aldehyde is converted to the alcohol, that is CH2OH. Other one possibility is that is converted to alcohol and this convert to salt. This is convert to alcohol, CH2OH, and this convert to salt. First possibility, which one? This convert to salt and this convert to alcohols. Another possibility, these convert to alcohol and these convert to salt. So 4 products are possible in Cannizzaro reaction, right? And next product, this benzaldehyde can treat with formaldehyde to get only one products. To oxidize and to get aldehyde get reduced to alcohols by strong alkali, CH2OH and plus sodium formate. So this is a cross Cannizzaro type of reaction. Intramolecular Cannizzaro reaction, it means the two dialdehyde can use. This is the intramolecular cross Cannizzaro reaction, and this is a cross Cannizzaro reaction.